I provide a free class every Thursday night, and we're going to cover JavaScript. And we're about halfway through, or week 10. And in here, we're creating a JavaScript compiler written in JavaScript. So down here at week 8 and 9, there's a compiler maker. We go into it. This is the compiler we're writing. This is a JavaScript compiler written in JavaScript. So I want to cover some of the menus and examples that we have. This first tab is the JavaScript. This is this JavaScript that we want to compile. This is the language that we're going to use to compile it. It's partial. It's not a complete list. It's a start. And so what we have here are the language. This is the language we're looking at, and we're looking at the base. The base is simply the general constructs of a language. So we have a definition of an assignment statement, the braces, the parentheses, and all the Boolean and arithmetic operators defined for us, so no matter what language we're building, it pretty much do this. In here, the first part are tokens. The first part is system, simply system. This is a CG2 file, basically defines the system, the name, the case sensitive, and sample. So here's our system, which is JavaScript. It's case sensitive, and this is the first part is simply a sample if you wanted to run this. The next is tokens. So we have name, precedence, and order. So token simply is a tag, so we know which defined statement relates to it. Then we have a token name. These are the names coming out of the tokenizer. So we have a tokenizer that scans the strings and returns each token. And these are the names that it returns. So even though it's an equal sign, it is returning an equal as a type. In here, this column here is the precedence. Here, the first one has lower order than the next one, and so on and so on. So when we get down here to the plus minus precedence, plus minus has higher precedence or lower precedence than the times, and so this determines that. And so we have about 15 or so precedences, and this determines the order in which operators are performed. So in this case, if we have an add, it will come before or after the times. So if I have A plus B times C, it'll be the partial will do the compiler will do a B times C, and then the plus A. Left simply means that this is the order that it'll be done in. So if I have A plus B plus C, it's going to do A plus B, and then that times plus C. So it's left ordered. Some equalities are right ordered, so that if I have A equals B equals C, it'll do B equals C and then A equals B. So we can determine the precedence and the order in this one table. And we can also give keywords. These are keywords that the partial will look up and then determine that this is the name of the token. Next, we have our language statement. These are reductions. Don't want to get into compiler writing, but if I have an ID coming out of, like an A coming out of the tokenizer, it'll have an ID of a type of ID, and then that will be reduced to an E. This first value is E value, which is a subroutine. Those are the reducers. Okay, so down in the reducers, these are the functions that will be called when a reduction needs to be performed. So if I can find E value here, it basically comes in and determines which of the tokens. So it'll be the result is always That's the E, which is the result, and then it's followed by the tokens. So P1 is the ID. So here I can add and build structures based upon that. So back in our language, we look at E plus E, so we just do E op E, which is our function, and that will create reductions, so on and so on. So that's our language constructs. What I've done is I've looked at base being the base language, which has all the arithmetic functions, some basic statements, how statements are built, whether they're complex statements, which is there's a parentheses and then you can have one or more statements, or you can just have a single statement. It also has functions in here so that it will separate your statements into functions which are hierarchical in nature, so that B can be a subfunction of A, and so on and so on. And then those all that's all this in the base language. So these 116 statements define a basic compiler. We can then go in and define, I'm going to extend this, but right now I have 3 statements that are more complex, and I've separated them out so that we can look at them. And so we have the if statement, which will be an if followed by a condition, which is going to be a Boolean or whatever expression there is in there. And then that's going to be followed by one statement, or it could be followed by one statement with an else followed by one more statement. One statement is simply a single statement or something in braces. So that's how the if statement works. Okay. So we have up here, we have the selection of looking at the language, looking at the reducers. These are the reducers, or the functions that are called when you want to reduce a statement, and then that goes back into the compiler. We have the run. These are the statements for the if statement. So if you're going to interactively run this, which we can do, this is the function that's called when the if statement is found, and then that will run it based upon its determined logic within the structure. ToString, we list out these structures, and each statement is a little bit different. It can have its own syntax or structures, and this is basically the ToString for the if statement. And then these are the statements if you want to output the if statement as a simpler code. So I have basically the language, I have the reduction functions, I then have 3 stages that you can output the compiled structures into, which is just to run it, output it as a list, and assembler. So we'll be looking at those. Okay, we can build the compiler. And basically build compiler, it's all JavaScript. So it compiles, it takes all the JavaScript engine, it's actually going through our language, creating the state tables for us, and it generates source code. So the source code is simply this one file is your compiler. This will run it, this will list it, and it will also generate the assembler code. And then what we're going with this is once the assembler code's done, then we can produce an executable, and then we should be able to execute it on any machine that's out there. So we will create COF type of assemblers. So this file, you can actually run this in Chrome, Edge, IE down to version 5, so as low as my compiler would take me, Firefox, Safari, and DOS. So you can take this, you can copy this file directly to a DOS file, uncomment these few lines here, and this will actually run the compiler, generate a program out of it. So here I'm creating a new, this is the JavaScript compiler. So I say new JavaScript, this is the object constructor, and this becomes the compiler. And this one file has no includes. This one file does everything. Once you compile it, you create a program, and then you can either run it, generate assembler, or list it based upon your needs. Okay, and this file basically has everything in it. It's about, oh, let's see, it's 3,400 lines, but it has the parser, it has the state table. Here's the state table, which is generated. It's an LR1 state table. We can look at these. These are the internal tables for the compiler. So this is a standard LALR, or compressed table of all the states, of all the tokens, and so the compiler simply goes through this to compile your language. So these are all built for you, and then the state table in your source code is a final representation of those states. We'll probably compress this down just to numbers, but for the class example, I decided to just go ahead and list everything in. So these are all the productions that we're going to produce, and these are the statements. These are the functions that are going to be called based upon each of these reductions, and then these are the state table. And it's basically given a token, it will do either a shift or a reduce. This is just standard compiler logic. In here you have, it builds and based upon what you select, it puts all your reduction tables in for all your statements. I'm hoping to add a lot more statement types. Here's the parser with all the equality statements, Boolean operators, a shift based upon precedence. Basically, I've grouped them so that there's precedence, and then I have opcodes of, and these simply are the opcodes that JavaScript have. If you have a different language, you just simply change your syntax and produce that. Basically, out of the parser or the tokenizers, basically it's going to call next token, and this is the main routine of the parser. Come in here, and this will scan your source code character by character and return the tokens. For strings, it parses it out, removes all your escape sequences. It does all that. For numbers, if it's floating point, it converts it. If it's binary, it converts it hex or octal. It will convert the number into a number and not leave it in its original form. So that's all done for you. So simply when you get into the compiler, you simply put in a number. Okay. And here you have this is the build function, which is simply putting all the pieces of the compiler and generating the source code for us. Here's the engine. This is the compiler engine that will come in, get the next token, and then process that token. So if it's a comment, a line comment, or a block comment, it ignores it. Otherwise, it'll process it until it's done. And this is the process token. This is simply the engine which goes through each of the states. I created a lot of data here, but most of this is simply get the token. Is it a positive number? Then shift. If it's a negative number, then do a reduction. Call one of those reduction functions based upon the compiler state table, and so on. So this routine of something like 60 lines is the compiler. Okay. So, and then you have your structures. This is the compiler. I've pre-built these so you can call and add. Basically, we want to keep and create statements like assign A to B, things like that. And then the robot. This is the overall entry point for the compiler to build the compiler. You simply give it, say, and this is not part of the source code. This is simply this interface. Okay, and then in the source code, sorry. Anyway, so now that we run it, we can compile it. We can compile the source code, and so we took this source code just now, and we compiled it, and it compiles into a main routine and any of the functions. So the main routine has these statements. So here I have a math assignment statement of basically taking the value 0. If it's positive, it's coming out of the values table. If it's a negative number, it's coming out of a temporary table. So if I add a plus b, I'm going to stick that into temporary -1, so on and so on. So we have this table which simply says do the assignment, compare value 1 to value 3, and value 1 is a number of 45, or value 1 is A, and value 3 is B. So it says compare is A less than B. Simply does that. Then it will add, then it adds the result and puts it in -2. Anyway, it creates a basic structure. And so now that we have this structure, we can actually run it. So we run it, and it's simply doing the thing that we told the compiler to do in our statement, which is down here, here's another listing of that source code. So it's got A and B, and then it does alert, and it's just validating that these operators are working properly. And then it comes down here, it says, okay, call this function with 4, and then it does a while statement. So we have the basic structure, some of the structures of JavaScript being compiled. Okay. Now, you can compile and run it, or you can generate an assembler. I'm working on this. This is simply a very crude representation of assembler, but it's telling us to do, move value 0 to value 1, and so on and so on. And this will be optimized. We'll come down and actually generate the assembler for JavaScript, which is, well, when we get down into it, how do you create objects? How do you do string and number compares? You have to determine which operators you want to do and that kind of thing. And we'll want to optimize a lot of this because some of them are straightforward. Yes, A is a number, B is a number, and then just go ahead and generate the simple code because they're constants, and so we'll be doing some of that. But this is simply will be assembler, and once we get this properly formatted and structured and all the function calls that we need, we'll be able to generate assembler code. So this is the compiler. Just wanted to give you a brief overview of what you were looking at, and hopefully this helps. What I'm trying to do is I'm trying to show how JavaScript works by actually seeing how an if statement is compiled so that we can determine its logic. We can then hopefully build the complete JavaScript, and we should be able to create a Node.js or some of these other environments. I don't have a server-side JavaScript that I can rely on, and I'd like to just compile it into assembler code. I'd like to add assembler code in JavaScript so I can say, look, you put 12 into register 1 and shift it and multiply, do straight assembler code from JavaScript. I'd also like to put in SQL statements. Here's a, select star from database. Anyway, we'll expand it so that we'll tie this directly into the database. We won't have to look at it. We can just simply reference it to file system and so on and so on. So we can get rid of a lot of our syntax, and we'll be able to create a better environment, at least for me. Anyway, this is the compiler. It's all in our class, The class is free. I probably won't do this again, but this is a good example of what you want to do in JavaScript. I appreciate your time, and hope you enjoyed this. Bye now.